Molecular cloud. A molecular cloud, sometimes called a stellar nursery, if star formation is occurring within, is a type of interstellar cloud. The density and size of which permit being absorption nebulae, the formation of molecules, most commonly molecular hydrogen, H2, as well as the formation of H2 regions. This is in contrast to other areas of the interstellar medium that contain predominantly ionized gas. Molecular hydrogen is difficult to detect by infrared and radio observations. So the molecule most often used to determine the presence of H2 is carbon monoxide, CO. The ratio between CO luminosity and H2 mass is thought to be constant, although there are reasons to doubt this assumption in observations of some other galaxies. Within molecular clouds or regions with higher density, where much dust and many gas cores reside, called clumps. These clumps are the beginning of star formation if gravitational forces are sufficient to cause the dust and gas to collapse. Occurrence within the Milky Way. Molecular gas clouds account for less than 1% of the volume of the interstellar medium, ISM. Yet it is also the densest part of the medium, comprising roughly half of the total gas mass interior to the Sun's galactic orbit. The bulk of the molecular gas is contained in a ring between 3.5 and 7.5 kiloparsecs, 11,000 and 24,000 light-years, from the center of the Milky Way. The Sun is about 8.5 kiloparsecs from the center. Large-scale CO maps of the galaxy show that the position of this gas correlates with the spiral arms of the galaxy. That molecular gas occurs predominantly in the spiral arms suggests that molecular clouds must form and dissociate on a timescale shorter than 10 million years, the time it takes for material to pass through the arm region. Circinus molecular cloud has a mass around 250,000 times that of the Sun. 6. Vertically to the plane of the galaxy. The molecular gas inhabits the narrow midplane of the galactic disk with a characteristic scale height, z, of approximately 50 to 75 parsecs. Much thinner than the warm atomic, z from 130 to 400 parsecs, in warm ionized, z around 1000 parsecs, gaseous components of the ISM. The exception to the ionized gas distribution are H2 regions, which are bubbles of hot ionized gas created in molecular clouds by the intense radiation given off by young massive stars, and as such they have approximately the same vertical distribution as the molecular gas. This distribution of molecular gas is averaged out over large distances, however. The small-scale distribution of the gas is highly irregular, with most of it concentrated in discrete clouds and cloud complexes.